So we start off with slope. Good old faithful here. You learned this in Algebra 1 and pre-algebra, I think, before that. Um, and to find slope, usually if you have a graph, you can count, the rise over the run. If you don't have a graph, you can use 2 points, and those 2 points can find you the slope. Um, and basically, slope is it's always been thought of as the average rate. So here are three terms that are synonymous with just good old-fashioned slope in this class. Average velocity, the average rate of change, and most importantly, because it comes up often, I mean all three of these do, but the slope of the secant line. Um, Now this secant is not your trigonometry secant, okay? So don't get them confused. Now, we do just normally find slope by using 2 points. So for example 1, we're just going to go ahead and do that. We're going to find the average rate of change of this function over the specified interval. Now my interval is telling me that x is equal to 1 and x is equal to 3. And so if I'm going to do the slope or the average rate of change with the familiar y2 minus y1 over x2 minus x1, then I'm going to need the y's. And to find the y's, you just take the function and plug in the x's, right? F of 1, f of 3. So if I plug in 1, I get 1 minus 1, which is 0. So y is 0 for that first point. And then if I plug in 3, I get 27 minus 3, which is 24. That's the y for the second point. So here are my 2 points, right? 3, 24, and 1, 0. Okay, so for the average rate, sometimes you'll see problems where it's dealing with speed and time, and you might see a slightly different version. I'll write it on the top here. So you'll see like s of t 2 minus s of t's 1 over, wow, brain fart, t2 minus t1. So time and speed, position, um, the position is determined by time, could be minutes, could be seconds, whatever. That's another way that you'll see it. Okay, so average rate. So back to actually finding or answering this question. So we do stick to y2 minus y1. You know what? I want to write it in a slightly different way. So it's going to be x of 2 minus x of 1. But instead of y, I want you to get used to f of x minus another f of x. Okay? Remember, f of x is y. Can't stress that enough. F of x is y. They're the same. F of x is just friendlier when you're wanting to show what you're plugging in for x. Okay, so so let's see. 24 minus 0 over 3 minus 1. So we get 24 over 2, which is 12 units. Whatever, because we don't have any units here. But there you go. There's your average rate of change. Okay, now keep this in mind and keep this format in mind. Get out of the y2 minus y1 over x2 minus x1 habit. Let's start looking at f of x. Okay, so example 2. For example 2, I need to ask the question, how do you find the slope of a linear function? And hopefully you're like, well, the way we just did it, we find it with 2 points, and that would be correct. That's how you find the slope of a line, of a function that is a line, a linear function. It doesn't matter what 2 points you use or you choose, right? Like here, we could use, let's do 3, 3, and 2, 1. It would be the same if we use these 2 points or any other 2 points. That's the beauty of a line. The slope is the same for the entire line. And the reason I'm talking about this is because in calculus, we mostly deal with curves, functions that are curved, not just straight lines. So because it's curved, the slope differs from point to point. And because of that reason, we can't just pick any 2 points and find the slope of those 2 points and it's the slope for the entire function. That's not how calculus works. So we go from using 2 points in Algebra 1 to find the slope of a line to calculus where we no longer have just straight lines, we have curves, and they make you find the slope by just using 1 point. All right, for this one it should be pretty easy. You could just do any 2 points, but I mean, if you recognize this function being written in slope-intercept form, then you should probably know, oh my god, I can't write. You should probably know that the coefficient of the x term, right, the number in front of the x, that is your slope. So here the slope is just 2. Okay, now onward to the actual calculus. So here is the definition of a tangent line with slope m. Tangent line. So let me explain that real quick. So let's say here I have a graph, and I'm focused on the slope here. Well, in calculus, when we want to find the slope of that point right there, because remember, I can't use just any 2 points and find the slope of the whole thing. Look at this curve, it's all over the place. We're going to find the slope of just a single point, and we're going to use the idea of a tangent line. So let me draw. That's good. That is a line that is tangent to the curve. Just think of next to. I'm not talking about tangent as in trigonometry. Kind of like earlier when I said the line of the secant, or the slope of the secant. Same thing, I'm not talking about secant as in trigonometry, so I'm not talking about tangent as in trigonometry. So there would be my tangent line. So here is a very complicated definition. I'm not going to waste your time with it right now. I'm just showing it to you. This is, oh, I can't write. This is how we're going to find the slope. Might look a little scary, but it's really not that bad. So that's how we're going to find the tangent, slope of the tangent, because the slope of the tangent is the same as the slope at this little green point. Okay. So, example 3 is find the slope of the tangent line to the graph of y equals x squared at the point 2, 4. So I have this little blue line here. Well, here's 2, 4. And that's like representing my tangent line. So we're trying to find the slope of that line because the slope of that line will get me the slope at this one point. It is normally referred to as the slope of the tangent or instantaneous slope or instantaneous rate of change. And in the near future, and when I say the near future, I mean like the next video, we're going to call it derivative. Okay, so derivative, the slope of the tangent line, instantaneous rate of change, which is very different than average rate of change. Instantaneous rate of change, the rate of change at that instant, that one point, and velocity somewhere in the near future. Okay, so all three of these things plus this, 4 things, that's what they're called, and the process is the same exact thing. You're trying to find the slope. Okay, so I have to ask the question, how do you find the slope of a curve? So as I said, in finding the slope of the curve, because the slope can be different for every point, we just find the slope at each point. Okay, so usually sometimes they'll specify a point, like in this example, and you're finding the slope there, not for the whole curve. You have to keep that in mind. And we do it by using the tangent line. Now, how do we do it by using the tangent line? Well, we're still going to kind of use 2 points. But you just said we're only allowed to use 1. Yes, you're right. We were given this point here. right? Which I'm going to refer to as x and f of x. Okay, so there's my original point, 2, 4, but I'm going to call it x and f of x as well. Okay? I need another point, but the idea is that this point has to be really, really close to 2. Let's ignore the 4 for right now. Let's think of the x. See, I want my new point, which I guess I'll do in red. My second point, I want it to be really close to my original x. So let me give you an example. A number that's really, really close to 2. Oh, I can't write. Is that really, really close to 2? 2.001? Yes, right? And let's not worry about the y. It's not going to do us any good. So there you go. There's my point. But I don't really want to tie myself down to 0.001. So what I'm going to do is I'm going to call this 0.001, I'm going to call it h. Let's just use h. Why not? I hope no one has a problem with that. I feel like using h. So my new point, I'm going to call it 2 plus h. Oh, but wait. Maybe I don't want to call it 2 plus h. Maybe I want to stick to my x's and my f of x's. So I'm going to call it x plus 2. Okay, remember, the 2 is the x, and the 0.001, I decided, oh, wow, I said x plus 2, I'm sorry. I don't know why I did that. X plus h, well, the x is 2, and I decided that the 0.001, that little bit of difference between my original point and this point, I was just going to call it h. So the idea is that this is 2 plus 0.001. Okay. Now, back to the blue part up here. I wanted to call the 2, 4 x and f of x, where f of x is just the function with the x plugged in. Okay, so I'm going to mimic that down here in my new point. I'm going to have my function, f, with my new x plugged in. Oops. There we go. Okay, so let's get rid of all this gibberish right here. Hope I haven't lost you. So here are my 2 points. My original, I'm just going to call x and f of x. And my new point, my arbitrary point, the point that I kind of basically made up, is going to be x plus that little extra bit, and then my function with that new x plugged in. So I'm going to do the whole slope formula with these values here. Okay, so let's pretend we're doing slope here. Right? So y2. Okay, so let me go ahead and label these. Maybe that'll help. So this is my x1, and this is my y1, and this is my x2, and this is my y2. So y2, so f of x plus h minus y1, which is f of x, over my x2, which is x plus h minus my x1. So there's my slope formula. Hopefully you could see that this x and this x cancel out. Right? So now I just have a little bit of a simpler equation, but no big deal. Okay, well, see this? This is the same as this scariness stuff right here. Just change the c for an x, change the delta x, oh, which I'm sorry if I forgot to mention, this is called delta, and it just means the change. Like how much was x changed by? Remember my 0.001? So change the c for x, the delta x is my h, right? Then minus my f of x, because we're changing the c for x. And then the delta x was how much did I change the x by, which was the 0.001, which I decided to call it h. Same thing. But notice, it's a limit. It's actually a limit as delta x, which is h, approaches 0. So that's how we're going to tackle this, with the limit. Now, I am going to admit to you, this is the long way of doing the derivative. The derivative is a very important topic in calculus. We will not always do it the long way. This is preliminary. It's right now. I will show you how to do things with this format, how to read it, how to break it down. Oops, it's H. I'm trying to erase this. How to break down this format to give you the answer without having to do the long way. But you still have to learn it. Okay, so here's the limit. And now that I figured out what my slope is going to look like, I'm ready. I'm confident to actually use this with my function, with y equals x squared. Okay, so the function was x squared. So the limit as h approaches 0. Now, the first part is my function with x plus h plugged in. So my function was x squared. So x would go in there, squared. But remember, this is not just x, it's going to be x plus that little bit. Minus f of x, which is just a function, x squared. Nothing plugged in there, right? Nothing extra, no little extra. Okay, factor, or not factor, let's see, expand, right? Distribute, basically, FOIL. So x plus h squared is actually x plus h times x plus h. So if you FOIL that out, you get x squared, and then x times h and another x times h. So 2 plus, or plus 2 times x times h. And then h times h is h squared. Minus my x squared at the end right here, right? And then divided by h. Once again, something cancels out, and that is the beauty of the difference, or sorry, this is called the difference quotient. And that is the beauty of the difference quotient. So I'm going to start on the next line. I have to write the limit again because it's a new line. Okay, proper notation in this class, important. And then I have 2 times x times h plus h squared over h. And then I see that my three terms, the two on the top and the one on the bottom, all have h in common. So I'm going to factor out the h from the top so that the one on the bottom cancels out. Again, you've got to love the beauty of the difference quotient. So now I have 2x plus h. Now I can safely plug in my h approaching 0, and I get 2x plus 0. So 2x. So here, this is my slope. But remember the 2 and the 4, the point at the beginning that I didn't use? This right here? It's not that I didn't use it or that I wouldn't use it. It's I wanted a generic answer because now I can use it. I can plug it in. So 2x, I plug in my x, which was 2. So I get 2 times 2, which is 4. So my slope at 2, 4, the slope is 4. Okay? Remember, the reason I used h was because I needed an extra point when I didn't have. And when I did pick out my h, it was 0.001 because I wanted it to be really, really, really close to 2. And being really, really close to 2 is just another way of saying approaching 0. Because 0.001 is really close to 0. That little bit, that difference that I added, I wanted it to be almost non-existent. And that's why we plug in, or when we're done with the limit, we plug in the 0 for h. So here's the slope.